हाँ शुरू करें. ओके, आई एम गौरव फ्रॉम X-2015 MP और आज हम लोग बहुत ही इंटरेस्टिंग सा एक रिवीजन वीडियो कैप्चर कर रहे हैं जिसमें कि हम ये बताने की कोशिश कर रहे हैं कि इस दुनिया में विचारों में तो शुद्धता नहीं बची पर शायद केमिस्ट्री में है. और जब हम केमिस्ट्री में शुद्धता की बात करते हैं, प्योर एलिमेंट्स की बात करते हैं, तो उनको दो तरीके से कैटेगराइज किया जाता है. एक को मेटल बोलते हैं, दूसरे को नॉन मेटल. अब ये मेटल मेटल क्यों होता है, नॉन मेटल क्यों होता है, इनकी क्या प्रॉपर्टीज होती है, ये दोनों मिलके क्या बनाते हैं, मिलने के बाद क्या गुल खिलाते हैं. ठीक है, ये सारी चीजें हमारे स्टूडेंट्स आज आपको बताने की कोशिश करेंगे.
Proceeding. Hi, this is Prakriti Yadav standing in front of you to discuss the physical properties of matter. Before proceeding the physical properties of matter, one should know what is malleable, what is ductile and what is brittle. Malleable means which can be beaten into thin sheets, ductile which can be broken into thin wires, and brittle which breaks on hammering. Physical properties of metals. Metals are generally hard and strong. But the hardness and strongness of metal does not vary from metal to metal. For example, metals such as iron, aluminium, copper, zinc are hard, but metals such as sodium and potassium are so soft that they can be easily cut with the help of knife. Metals are usually grey and silver in color, but gold and copper are exceptions. They are yellow and reddish brown in color. Metals are generally sonorous. Now, you think what is sonorous? Sonorous is a property of metal by which they produce a deep ringing sound when struck. Metals are lustrous, that is, they have a shiny surface and can be polished. Therefore, they are used to make ornaments and jewelry. In addition to this, metals have high densities as well as high melting and boiling point. But gallium and caesium are exceptions. They have low melting and boiling point. Moreover, metals conduct electricity and heat. Metals conduct electricity and heat because they have free electrons in their outermost orbit. From the above, metals are generally solid at room temperature, but mercury, which is an exception, is liquid at room temperature. From the above physical activities of metal, we can define metal as the elements which conduct heat and electricity, which are malleable, ductile, sonorous, lustrous, and etc. Thank you.
I am standing before you to tell about the topic physical properties of non-metals. First of all, let's start with the non-metals. The non-metals are usually brittle. That means they are not malleable nor ductile. They cannot be drawn into thin sheets or thin wire. Then the non-metals are bad conductors or insulators. Therefore, they are not used in any kind of circuits, electrical circuits and electrical appliances. The non-metals are bad conductor of heat. They usually do not conduct much of the heat. That's why they are bad conductor of heat. Then non-metals are not lustrous. They are dull in appearance. There is an exception in this. Iodine is exception. It has a shiny appearance. Non-metals are not non-sonorous. They do not produce any kind of sound or ringing kind of sound when hit by any object or anything. Non-metals have low density. For example, sulfur has a density of 2 grams per centimeter square, which is quite low. Non-metals are present in all forms of state, that is solid, liquid and gas. For example, solid carbon. In nature, carbon is present in solid state, bromine is present in liquid state, and gas, hydrogen, oxygen and nitrogen are present in gas state. Non-metals have different colors. For example, sulfur is yellow in color, graphite is black in color, and oxygen is colorless. Thank you.
Start.
Okay, start.
Hi, this is Ashutosh Tiwari. Today we are going to learn about chemical properties of metals. First of all, जब metal react होता है oxygen के साथ, so it forms metal oxide. So the first property goes like this: metal when combines with oxygen, it forms metal oxide. So let's see a reaction. Like for example, we have 2Mg plus O2 that gives us we will learn about chemical properties of metals. The first property is that when metals react with oxygen, they form metal oxide. Metal oxide are basic in nature, means that they turn red litmus to blue. Then if we see the second property of metal, so that is when metal reacts with water, it forms metal hydroxide. And metal also we can say metal oxide, means that when metals react with water, they form metal hydroxide, and when metal reacts with steam, so they form metal oxide. We all know that potassium and sodium are stored under kerosene oil. So why is it like that? The reason is that potassium and sodium are very high reactive. They when comes in contact with oxygen, they usually starts burning. So they are kept under kerosene oil. The third property of metal is that the third property shows us the reaction of metal with dilute acid. When metal reacts with dilute acid, so it forms metal salt plus hydrogen. And the fourth property of metal is that reaction of metal with salt solution. That is, when metal reacts with a highly reactive compound, so the highly reactive displaces the less reactive. And the fifth property is that reaction of metals with chlorine, means that when metals react with chlorine, so they form chlorides of the metals. The last property of metal is that when metal reacts with hydrogen, so it forms hydride. Thank you.
This is Manasi, and I am standing before you to present a presentation on a topic: chemical reactions of chemical properties of non-metals. Reactions with hydrogen. Non-metals react with hydrogen to form covalent hydrides. For example, nitrogen, oxygen, sulfur, chlorine react with hydrogen to form ammonia, water, hydrogen sulfide, and hydrogen chloride respectively. For example, N2 plus 3H2 gives 2NH3, that is ammonia, and O2 plus 2H2 gives 2H2O, that is water. The number of non-metals is much smaller, but they are the major constituencies of air, oxygen, and earth crust, followed by silicon. The two non-metals constitute about 74.3 by mass of the earth's crust. Second is reaction with oxygen. Non-metals react with oxygen to form covalent oxides. For example, carbon forms carbon dioxide, and sulfur forms sulfur dioxide. That is sulfur plus that is S plus O2 gives SO2. And phosphorus burns with a bright dazzling flame, giving white fumes of phosphorus pentoxide. This phosphorus Hp plus oxygen, that is, we can take 5O2, gives dioxide, that is C plus O2 gives CO2. The carbon dioxide gas formed in this reaction turns lime water milky. That is this is potassium hydroxide form acids. CO2 plus H2O will give H2CO3, that is carbonic acid. Or SO2 plus H2O will give H2SO3, sulfurous acid. However, some acids of these non-metals like carbon and hydrogen oxide are neutral. Reaction with acids. Non-metals do not react with acid. They cannot supply electrons to H plus ions of any acid and hence do not react. Reactions with chlorine. Non-metals react with chlorine to form covalent chlorides. For example, hydrogen reacts with chlorine to form hydrogen chloride, and phosphorus reacts to form phosphorus trichloride. That is H2 plus Cl2 gives 2HCl, that is hydrogen chloride. And P4 plus 6Cl2 gives 4PCl3, that is phosphorus trichloride.
हमने ये देखा कि मेटल नॉन मेटल की प्रॉपर्टीज क्या होती है, मतलब ये फिजिकली स्ट्रक्चर वाइज कैसे बिहेव करते हैं और केमिकली एक दूसरे के साथ कैसे आदान प्रदान करते हैं। बट अब इम्पोर्टेंट डिस्कशन जो आ रहा है वो ये है कि एक मेटल दूसरे नॉन मेटल के साथ पहली बात तो दोस्ती क्यों करना चाहता है, दूसरा एक मेटल दूसरे मेटल के साथ दोस्ती कर पाएगा कि नहीं, और एक नॉन मेटल दूसरे नॉन मेटल के साथ दोस्ती करना चाहता है या नहीं, इस दोस्ती का नेचर क्या है, इस दोस्ती का कारण क्या है, ये दोस्ती होती ही क्यों और दुश्मनी में कैसे बदलती है, ये सारी चीजें बॉन्डिंग की कहानी है। और इस बॉन्डिंग को समझाने के लिए आई एम इनवाइटिंग निधि।
Hello, I am Nidhi Goswami standing here to tell you something about the formation of bonds. There are two types of bonds, ionic bonds and covalent bonds. Ionic bonds, the chemical bonds which are formed by the transfer of electrons from one atom to another atom are called ionic bonds. The transfer of electrons takes place in such a way that the ions will have a stability, that is inert gas electronic configuration. The ionic bonds are mostly formed when metals react with non-metals. A strong force of attraction is formed when the oppositely charged ions react with each other, combine each other. So let us see with an example. Sodium has the atomic number of sodium is 11. Its electronic configuration is 281. When the sodium will lose one electron to become sodium ion. Chlorine has 17 electrons. Its electronic configuration is 287. It has 7 electrons in its outermost shell and needs 1 electron to complete its octet. So it will gain 1 electron to become chlorine ion. When the sodium and chlorine will react with each other, sodium will transfer 1 electron to the chlorine, and by gaining 1 electron, chlorine will become chlorine ion, and by losing 1 electron, the sodium will become sodium ion because they will complete their octet. This can be represented as this will give 1 electron to chlorine and become sodium ion. Chlorine will complete its octet with 8 electrons in its outermost shell and give NaCl. Now covalent bonds. Covalent bonds are formed when the sharing of electrons take place between two atoms. Covalent bonds are formed when both the reacting atoms need electrons to complete their octet. Mostly when a non-metal reacts with another non-metal, these covalent bonds are formed. The shared electrons are counted for both the atoms. Covalent bonds are of 3 types. First, single covalent bond. Single covalent bonds are formed by sharing 1 pair of electrons. For example, chlorine has atomic number 17. Its electronic configuration is 287. 2 chlorine atoms will combine and share 1 pair of electrons, that is 2 electrons, to form the chlorine molecule. They will share 2 electrons and become chlorine ion, chlorine molecule. The way the bonds for double covalent bonds and triple covalent bonds can be made. The example of double covalent bond is oxygen, and the example of triple covalent bond is nitrogen molecule. Thank you.
Shri Gaur is standing before you to put enlighten.
Okay, start.
Hi, it's Anushri Gaur standing before you to express the topic properties of ionic and covalent bonds. First of all, ionic bonds. Ionic bonds are usually crystalline solid because they are made up of oppositively charged ion which attract each another and forms regular crystal structure. They have high melting and high boiling point because their force of attraction is larger, and in order to break that force of attraction we require a lot of heat energy. Ionic bonds are insoluble in water but are soluble in an organic solvent because water has more dielectric constant, due to which ionic compounds are insoluble in water but are soluble in organic solvent because water has more dielectric constant, due to which it weakens the force of attraction between the ions of ionic compound. Ionic compounds conduct electricity when dissolved in water. When dissolved in water, because its structure is broken and ions become free to move and conduct electricity. Now comes covalent bond. Covalent bonds are usually liquid and gaseous at the room temperature because their force of attraction is weaker due to covalent bonds. Example urea, glucose, and iodine. They have low melting and boiling point. They have low melting and boiling point due to the weaker force of attraction. The covalent compounds are insoluble in water, but some are soluble and mostly are soluble in organic solvents. Like naphthalene is insoluble in water, but hydrogen chloride, glucose, and urea are soluble in water. Now, covalent compounds conduct electricity, but Cl, which is covalent compound, do conduct electricity.